Hello grade 12s. This is pretty much a video on the last little section on probability, something I call probability problems. Up until now we've been dealing with the counting principle and also with counting problems. So just figuring out in how many different ways something can happen depending on the restrictions that have been given. But the whole goal with counting all the number of ways things can happen is eventually to be able to calculate a probability. So I'm going to start off with an example, and then in the example I will just again mention the definition of probability so you can see just how these problems work. Just a heads up before you look at this video and you look at these examples, very rarely do they ask these. So I know they're going to be a little bit difficult, but you'll start seeing when you start working through the past paper problems, they don't really do anything this difficult in the exam, and if they do, it is normally very few marks. Okay, probability problems. The counting principle is used to solve probability problems. So in this first example, they say, determine the probability of randomly forming a word that starts with the letter W, ends with the letter F, using all the letters in the word willfully. And I have to state, repetition is not allowed here. Let's just make that very clear here. Repetition is not allowed. So, in order to answer this problem, I can't just calculate in how many different ways I can form this word. Because if you recall, the definition of probability says very clearly that when I calculate probability, I have to go and I have to say it's the number of ways an event can happen divided by the total number of outcomes. That's literally what probability means. The probability of an event A happening is the number of ways in which A can happen divided by the total number of things that can happen in the sample space. So when we work with these, we not only do have to calculate the number of ways this event can happen, in other words, starting a word with the letter W and ending it with the letter F, but I also have to go and figure out the total number of ways that I can form words using this. Okay, so that then means we have to first be able to figure out how many words in total can I form if there are no restrictions, because that's going to go to the bottom of this probability calculation. So no restrictions. There's the first bit. It's going to be a word that's got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 letters. But if you recall from our previous examples, we have to be careful for elements that are identical. So elements that look exactly the same. Again, this is not about repetition. It just has to do that in this particular word, I have 1, 2, 3, 4 L's. And those L's look identical. So they are identical elements, so moving them around doesn't necessarily give you any more variations. So be very careful. We need to go and realize that that is not going to give us more words or arrangements. Okay, so I've got one W, I've got one I, I've got those 1, 2, 3, 4 L's, I've got one F, I've got one U, I've got one Y. So I only have to worry about those 9 L's. So if there are no restrictions, we now know hopefully that that would be 9 factorial divided by the 4 factorial because of those 4 L's. This, if I calculate it, is going to give me 15,120 possible ways to form words using all of the letters, but repetition is not allowed. Now I have to look at the restrictions. So I have to look at starts with W, and ends with F. So these are what we refer to as statutes, meaning they have prescribed that the first letter must be a W, the last letter must be an F, so these are fixed, they are not available for choices anymore. So that then means what is available here in the middle of those 9 letters is we now have 7 letters that we could actually rearrange. So here in the middle we have that 7 factorial letters that remain, but again, there's still the 4 L's that are identical, which means that is not going to give me arrangements that look different. So now I have to go, it's 7 factorial divided by 4 factorial, just simply because the W and the F are not available. They fixed them. So that then means, if I type that in, 7 factorial divided by 4 factorial, that is going to be equal to 210. There we go. So now I can go and I can calculate the probability of picking out of all of these possible options, picking that word that starts with W and ends with F. And all I have to do is I have to say it's the total number of ways something can happen, 210, divided by, the number of ways this can happen, divided by the total of number of ways. That's what I meant to say, but not what I said. Okay, so it's 210 divided by 15,120. And again, you're perfectly allowed to leave it like that. If you want to, you can simplify the fraction. So we can say 210 divided by 15,120, and that's going to be 1 over 72. So I can just write 1 over 72, which is more accurate, because if you round it off to one decimal place, you're going to get 0.0, which you really don't want. And that's why generally, especially these ones, we kind of leave them either as an unsimplified fraction or a simplified fraction. It's probably a good idea to simplify the fraction, but that should be pretty obvious. Okay, I'm going to do another problem. Obviously, once we start looking through the past paper worksheets, we will encounter 1 or 2 of these, but very, very, very few. So when I do the next problem, again, please don't stress too much. This is not that important section of work. Okay. Right, so in the next problem. A password is formed using 3 letters of the alphabet, excluding the letters A, E, I, O, and U. So we are not using any of the vowels, which means there are 26 letters in the alphabet, but we are not using 5 of them, which means now we only have 21 letters of the alphabet we can use. And using then after that any 3 digits excluding 0. So that means we can use any of the digits, but we can't use 0, which means instead of having 10 digits available, we only have 9 digits available. The numbers and letters may be repeated, so very important. Well, I may repeat the letters and I may repeat the numbers. Calculate the probability that a randomly chosen word starts with B and ends with 4. So again, because they ask for probability, right there, that's the clue, probability. It's not enough to only work out how many of these codes, or passwords I should rather say, how many of these passwords start with B and ends with 4. I first have to go and calculate how many passwords I can actually form. So that's the first one. Calculate the number of possible passwords. So the number of possible passwords, we say we're going to use 3 letters, but I'm allowed to repeat the letters. Now, normally I'd have 26 letters, but I have eliminated 5 of them, which means I have 21 letters. So I have 21 letters, and again, because I'm allowed repetition, it means this is not a factorial, this is going to be an exponent. So I can choose out of 21 letters, and then I can again choose out of 21 letters, and then I can again choose out of 21 letters. Those choices don't get less because repetition is allowed. So I'm going to say it's 21 to the power of 3 times then, and then I have to use any 3 digits. Again, repetition is allowed. I can't use 0, so that means I have 9 digits available. But again, because repetition is allowed, it's not a factorial, it's an exponent, so it's 9 to the power of 3. So 21 to the power of 3 times 9 to the power of 3 means you have a possibility of 6,751,269 passwords you can form with this. Okay, so this is every single time when I calculate the probability. This is going to be at the bottom of my fraction when I calculate the probability. Now we have to go and look at the letters, the passwords that start with B and ends with 4. Okay, starts with B, and ends with 4. So there's letter B, that's fixed. that's fixed. I can't do anything about that one, but that one's been chosen. And it ends with 4. That's also, like I called it, a statue. That one's been chosen. So if you think about it, that then means we still have to choose 2 more letters. Now, just because I picked B on the first one doesn't mean I can't pick B here, because repetition is allowed. So that means I still have 21 available letters I can choose. But I'm only allowed to choose 2 because B has already been chosen as the first one. So that's 21 to the power of 2. And then just because 4 has been chosen over here doesn't mean I'm not allowed to use it. Repetition is allowed. So I can still go and I can use 4. So I still have 9 digits available, but I can only choose 2 because this one has already been allocated. So I can calculate this one. And that is again, that is going to be 35,721. And now I need to calculate the probability, which is going to be that divided by that. So I can just type this into my calculator, that divided by 6,751,269. And that's going to give me 1 over 189. Now the good news at least is I then don't have to go, and for the follow-up questions I don't have to go and calculate this one. This one I'm going to use in the bottom of my probability calculation every single time. So each time I'll just come back to this one. So whatever other restrictions they give me, whatever else I calculate, I'll just every single time put it over that. Okay, so the B part of this one says, what is the probability that the password that is randomly selected has exactly 1B? Has exactly 1B. Now this one can be a little bit tricky, and the reason it's a little bit tricky is the following. Yes, having exactly 1B means I could have a B in the first one, and then the rest are all different. Or I could have a different letter in the first spot, B in the second spot, and then the rest are all different. Or I could have had a different letter than B, a different letter than B, and then B in the third spot, because remember we allowed 3 letters and then the rest. So the first thing you need to realize is you need to realize there are 3 places that B can occur only once. Unlike the previous one where the space was fixed, where they said it's got to be the first one and the last one, here they just said you have to have a B and only one B. But that means that that B can be in the first position for letters, in the second position for letters, or the third position for letters. So this can happen in 3 different ways. And that's why I have to start by saying there are 3 different ways that this can happen. Let's look at the rest. I still have 2 letters that I can choose. But very importantly, I can't choose another B because I need exactly 1 B. So that means I no longer have 21 letters available here. I only have 20 letters available, and I only have 2 places in which I can put it. Then my 3 digits are all still available. So I can still use all 9 of the digits, and I have got 3 spaces to put it in. So that's 9 to the power of 3. So if I calculate that, that's going to be 874,800. And again, because they're asking me for the probability of this happening, I have to place that 874,800. I have to place that over that 6 million that I calculated previously. So the 6,751,269. And I can then divide that one by 6,751,269, and I end up with 400 over 3,087. There you go. I'm just going to check this answer. Just pause. I'll just confirm whether it's right or not, because sometimes even I look at it and I go, I hope that's right. I'll be right back. And this is in fact the correct answer. I did double check it in the back of the book that I found it, so I know this is the correct answer. Okay, next one. The next one is quite a tricky one. I was actually debating whether I should show it to you guys or not, but let's have a look. Let's have a look. This one says, what is the probability of creating a password or randomly selecting a password that has at least 1 4? Okay, now what makes this one tricky is the following. If you have at least 1 4, then you realize those first 3, which are the letters, that's up for grabs. I can do whatever I want over there. So that's not a problem. But if you look at the last 3, which are the digits, I potentially there had 1 4. Okay, or I could have had 2 4s, or I could have had 3 4s. Now, having 1 4 means that 1 4 could have appeared there, or there. So 1 4 could have appeared in 3 places. So if I had 1 4, there were 3 places that it could have occurred. Okay, then I could have had 2 4s. Now the problem with 2 4s is there's quite a few here. I could have had a 4 there and a 4 there, so that's 1. I could have had a 4 there and a 4 there, so that's 2. I could have had a 4 there and a 4 there, so that's 3 again. So there again, I could have had it in 3 different ways. So 3 places, or I could have had those 2 4s in 3 permutations, if that makes any sense. Well, let's just say in 3 ways. Now the good news, if I had 3 4s, because remember at least 1 4 means I could have had 1 4, I could have 2 4s, or I could have had 3 4s. If I had 3 4s, there was only one way for this to happen, which would have been a 4, a 4, a 4, done, only that one way. Okay, right. Now that then takes care of the number of ways I can place those 4. So I can say I can do it in 3 places, I can do it in 3 ways over here, I can do it in 3 ways over there, I can do it in 1 way over there. Now what we need to do is we need to then say to ourselves, okay, and like I said, this is why this is a fairly tricky one. I have to say to myself, first things first, those 3 letters at least, nothing's changed there. I have 21 available and I can put it in 3 different spaces. Okay, then the next thing I can say is I can say, okay, I put a 4 down, only 1 4. But I can put it in 3 different places, so there were 3 places where I could put it. But that then means I've used my 1 4 for this one. So that means the other 2 can't be 4. We'll look at them over here. So we'll look at them over there. So that means my other 2 available ones, I no longer have 9 digits, I only have 8 digits to put in 2 different places. So that's if I use the 1 4. Then what I could have done is I could have said, or. Again, 21 to the power of 3, at least that doesn't change. That is the 3 letters I can pick however many times and put wherever I want. But then I'm using 2 4s now, and I can do it in 3 different ways again. So that's 3 different ways. But that then means that I only have 1 other digit I can choose. So because I only have 1 other digit I can choose, it means 8 that I can choose, because obviously I can't choose 4. 4 has already been chosen to the power of 1. Plus, and then the last one, hopefully you're seeing the pattern here, is then 21 to the power of 3 times 1 way to put all those 4s. And then if I've put all those 4s down, there's no longer place for any other digits. So that means I'm not going to multiply by anything else. That's it. So if I do this one then, let's see what I get. So that plus 21 to the power of 3 times 3 times 8 plus 21 to the power of 3 times 1, which is just 21 to the power of 3. Then I get 2 million. Is that 2 million? Yes, that's 2,009,637 ways that I can do it. So I'm going to put that 2,009,637 ways that I can do it over that previous answer, which is the number of ways, the 6,751,269. So let's just divide that. And that's then going to be 217 over 729. And I'm again quickly going to check the answer in the book, just to double check to make sure I'm not lying to you. Otherwise, it would be horrible to have a fight about this answer if I'm actually wrong. So according to the book here, this is 217 over 729. This is the correct answer. So this is the correct answer. I'm not making this up. But like I said, a lot of the time with these ones, there are so many possibilities and there are so many things that you might not think of. And there are different ways to do this as well. I'm sure if you tried on your own, you might come up with a different way of doing it. So as long as you come up with the same answers I do, it's absolutely 100% fine. Thank you very much for listening.